All right, so 3.4 here in your textbook, it's called Applications of Set Theory. So this is what it looks like in your Foundations Math 12 book by Nelson Publishers. So we're going to start off by taking a look at the very first example. It's called the Investigate the Math example. And in 3.4, we're taking a look at 3 Venn diagram circles instead of 2. So in 3.1 and 3.2 and 3, we've only taken a look at a maximum of 2 subsets within the universal set. But today we're going to look at 3. And it becomes just a tiny bit more complicated with 3, but let's go over this. So the Investigate the Math gives us a situation that looks like this. Rachel surveyed grade 12 students about how they communicated with friends over the previous week. So 66% called on a cell phone, 76% texted, 34% used a social networking site. So you can kind of see how the circles are set up. C, S, and T are these sections here. The next bit of information we have is that 56% called on a cell phone and texted, 18% called on a cell phone and used social networking sites. So that's the intersection, if you remember, from 3.2. 90% texted and used social networking site. 12% used all 3 forms of communication. So we've got all these sections here, and this first example, we want to place all these in the Venn diagram. So a couple things that we want to remember. The total, okay, for the cell phone is 66%. And that means that inside this whole circle right here has to be 66. Now, they don't give us a total of the students, which is fine because this is a percent. So the total is 100%. And I've had students say stuff like this, like, well, I don't know how many students I'm supposed to be counting. And if it's in a percent is always per 100. So there is a total of 100% here. Not necessarily 100 students, but 100% of all students surveyed. So you're going to have to make sure that we have 100 in this universal set when we're all done. Okay. So you could start by putting 66 in here, but we don't know how many are in these sections as well. So this is what I would suggest for this type of question. I would suggest starting with this middle section first, if you can place that. Always start in the middle. So that's the number of C and T and S. That's what this middle part is. And if you can identify that, you want to place that in your Venn diagrams first. Very important rule, I would say, that we should always do that. And that, of course, is the 12% here. Used all 3 forms of communication. So I'm going to put a 12 right in there, because it's easier to kind of work out from that. You're going to add instead of subtract. If we started with a 66, I would work down the list and I'd have to be subtracting always from 66. And this way, we can work out. It's going to be easiest. All right, so let's work out from the middle. Let's look at these 3 sections if we can find out what numbers go in there. So in this case, we're going to have to work up the list. So 19% texted and used the social networking. So that's between T and S. That is this entire region right here, okay, is T and S. So I need to have a total of 19 in there. Notice that I already have 12 that's in this section. So how much needs to go in here? This is 7. Okay, so 7 needs to go in there. And now we've successfully filled another section of the Venn diagram. And just for future, we're going to do another example with this here too today. But this is actually used, this section 7 is the number of students that used texting and social networking only. So you're going to see an only in another question, and that's the only part would be this, only. T and S only. So that's what this actually is, the 7. Okay, let's keep going. 18% cell phone and social networking. So C and S has got to be 18. Already got 12, so this is 6. Why? Because again, 12 plus 6 has to make up this region, 18. So there we have it. All right, keep going. So 56% cell phone and texted, so C and T. 56, okay. So that means in this overlap region, we have to have 56. If I have 12 there already, this is going to be 44. Make that a bit bigger. 44. Okay? So you can see how it's easy just to kind of add to that middle one always. Add to the middle one. All right, last three. Let's take care of the last three here. So 34% use the social networking site. So remember, that's the entire circle of S has to be 34. So I have 12 and 6 is 18, and 7 is 25. So I need 9 in this section. Okay, this is social networking site only. Okay, this is social networking site only right here. All right, let's keep going with that. And 76% texted. So I need to add up these three numbers that I already have, and then a leftover part will be adding up to 76. So 44 and 12 is 56, and 7 is 63, and then this would be 13 to get to 76 in total. And finally, 66%, so that's 56, and 6 is 62, so it looks like only 4% used a cell phone only. Okay, anybody have any questions? You guys are a smart class. Yeah, you're picking this up pretty quick. 2.3, are we above 2.3 now? A little bit? Okay. All right, this is good news. Okay, so that's how we label, how we plot that diagram. Now, the next little question here is not a Venn diagram question, it's just a concept question, so I just wanted to ask you this. Just remember that sometimes circles can be overlapping. We don't want to double count people. So in this case, Sarah conducted a survey, and she found that 20 teens clicked off the box that they play online games. 20 teens play game consoles, and 20 teens play on their cell phones. But she only surveyed 31 in total. So how can this be? We have 20 plus 20 plus 20. That equals 60. But of course, we understand that these are not disjoint sets like this, right? But instead, these are overlapping sets. So some teenagers might do more than one thing, obviously. And this 20 could actually be separated into, some of it goes to that section, some of it goes to this, some of it goes to this. So it's actually not a full 20, a full 20, and a full 20 that we add up. Right? Good? Okay. So here's where 3.4 gets a little more complicated, all right? So Venn diagrams graphically or visually is one thing. Placing numbers in a diagram, great. I think we're pretty good at that. This is where we now revisit the principle of inclusion and exclusion with three sets. So don't get frightened here because this looks pretty scary. Let me walk you through what this means, because when I show you what it looks like on this Venn diagram over here, it's not going to be that scary, okay? But remember, with the principle of inclusion and exclusion, we're trying to add up all of the numbers, but we're trying not to double count anything. That's why we have to subtract some things, okay? So we know about this. So let's walk through this, and then I'll get to this adding here, and we'll find out why that is. So I want to show you visually why this formula works, okay? So the number of A union B union C. So that's everything, okay? That's everything in A and B and C. So I am going to count all of these sections like that. A union B union C. That's everything, okay? Now that's what I want to count. So how does this side add up to this? Well, let's take a look at that. I'm going to erase all these, and I'm going to show you how the right side, by using these little red lines, how they add up to the left side. So the number of A, okay. So the number in A would include all the numbers that would be in all three of these sections. Great, the number of A taken care of. The number of B would be all of the numbers that are in these three sections as well, and already you can see that we've double counted any that might be in this overlapping spot. Let's keep going. If we add the number of C, now we're adding the values that would be in these three sections as well, because these are all in C. And we can actually see that we have double counted some sections and triple counted the middle one. So that's why I'm going to start to take away now the number of A and B. So A and B would be the numbers in this section. I'm going to take away kind of one set of those that I've counted. So here goes one, and there goes one. That's what this represents. This one represents a taking away of the number of A and C. So that's the number, that's the values here. I'm going to take away one set of those, and that's going to get rid of this and this, A and C. I'm also going to take away the number of B and C. So that's, so B and C would be this and one of those. Just one. So up to this point, you can see that I've counted just once in these sections, but I have nothing to show here. I've actually taken away all three of these. Like, I've taken away everything from here. So that's why we have to add back in the intersection of A and B and C. So I put one more in there, and voila, we have everything in every section counted just once. Now it may be true that some of these may equal 0, right? We may not have to, there might not be anything in A and C, I don't know. But the formula will hold true. So this is the formula for counting everything in 3 sets once.
If for one of the ones it's like negative N, A, and C, if they don't give you something, would that all be 0? Would that still be negative?
Yeah, so if there is nothing in A and C, okay, if there's nothing in A and C, that means there would be no elements in this section, so you would just subtract 0 then, yeah. It would be like a 0. Now, well, oh no, here's the thing. For this question that we're going to do, they are actually asking how many children, I'm looking ahead here, have a cat, a dog, and a bird. So they're asking for how many would be in this section. So as we move through this question, you'll see that there will be something here. So there's going to be a value for this. But if this did not exist, or if there wasn't anything here, then you could just subtract 0, and you don't even have to worry about it. Okay? So let's take a look here. And we're going to use this formula now to work at this question. Okay, so this is the trickiest part of this 3.4 for sure, but I'm going to walk you through it. It's going to be great. All right, so 28 children have a dog, a cat, or a bird. So it looks like 28 is going to be our total that are in these 3 circles. Okay, so they have a dog, cat, or a bird. So 28 is going to be our total that are going to be in these 3 circles. 13 children have a dog. Okay. So let's back up here. It looks like 28 is going to be representing this, okay? That's what this is, the number of A union B union C, 28. Now, 13 children have a dog. So the dog is actually A, the bird is actually B, this makes sense, and the cat is C. So if we walk through this, 13 children have a dog. So that's A. That's the number of A, 13. I'm not necessarily going to, well, I guess maybe I will. I can fill this out, I suppose. You don't have to fill out the Venn diagram, though. That's why we're using this. So I'll tell you what, I'm just going to hold off on that. So we've got 13 taken care of, it's right here. Also 13 have a cat. That would be the number of C. So in C there should be 13. Whoops, okay, so that's over here, 13 I guess. Here's number of C. And 13 have a bird. So here's the number of bird is also 13. Okay? Now if you add these 3 up, you get 39, which is more than 28. So that's a problem, and what that means is there's some in the overlapping areas. So let's keep going and read the question. 4 children have only a dog and a cat. Okay, this is a bit different. In the last example, let me just show you. The last example that we didn't see anybody, there was no onlys. And remember I said that this section right here was only T and S, only. So let's go back here, and on this diagram, only a dog and a cat would be this section right here. See that? Okay, only a dog and a cat. Now I have a problem, because this is not only, okay? This right here is all in A and B. That's this whole thing. And I'm not given the value for that. So let's find out what the problem is. Well, the problem is actually this. I actually don't know how many kids have a cat, a dog, and a bird. So this is what we're actually trying to solve for. So this is where you kind of have to read through the question and figure out where our unknown value is, because in an equation, you have a bunch of numbers, but then you have something that's unknown. That's why we're using an equation. So how many children have a cat, a dog, and a bird? That indicates this section right here, and I don't know how many are in this section, so I'm going to leave it to be the variable x. So right away, I can actually go over here to this one, And this is going to be our unknown variable x. Okay? You with me so far? You good? Anybody else? All right? Okay. All right, so 4 children have only a cat and a dog. So that means that 4 goes here, and I can now represent number of A and B. That is this right here. Okay, so now I can put something in the equation. And that something is going to be 4 kids plus x, or some unknown number of kids. So this is going to be minus 4 plus x. And that's the tricky part. Now we've got to the tricky part of this section. Okay? This type of question where there's an unknown buried in this. Any questions? All right, let's keep going, see what the other ones seem to say. We got that taken care of. So 3 children have only a dog and a bird. Only a dog and a bird. That's this section right here. So what goes in there? 4. Nope, 3. 3, sorry. 3. 3. Okay, so that's dog and a bird only. So where's dog? Yeah, dog and a bird here. That's dog. This is, nope. Oh, okay. I put my 4 and x in the wrong spot, sorry. That's dog and bird right here. So 4 and the x was, what was that? Dog and a cat. Okay. Oh, here's dog and a cat. So this is 4 plus x. My apologies. This one here, if I'm putting this underneath here, this is 3 plus x. You see that? 3 plus x. So I'm just going to rearrange those there for you. Good? All right. So bird and cat. Okay, we have bird and cat. Yeah, cat and bird here. Only cat and bird is 2. So only cat and bird, that's this spot over here, that's 2. So cat and a bird in total is 2 plus x. Cat and a bird in total is 2 plus x. So let's review this real quick. Dog and a bird is dog and bird, that's this right here. So that's 3 plus x. A dog and a cat is dog and a cat is right here. So that's 4 plus some unknown. And a bird and a cat is right here, 2 plus some unknown. All right, now this is a basic algebraic expression now. So what we're going to do is we're going to solve for x. Those of you that aren't math people, let me walk you through this. We're going to have to get rid of some brackets. Going to have to distribute this negative sign a bit. And then we're going to gather like terms, and it's not going to be too hard after that. So let's take a stab at it. All right, so I have 28 equals, and I'm trying to solve for x. So I want to get these x's all together. First thing you want to do, well, let's add 13 together 3 times. So that's 39. And when you have a subtraction of something inside brackets, you want to distribute that minus sign, okay? So this is actually subtracting 3 and subtracting x. So I'm going to write that, minus 3 minus x. This is like minus subtracting 4 and subtracting a positive x, so that's minus 4 minus x. And when we subtract this, that's minus 2 minus x. Good to get rid of the brackets, okay? So they aren't messing you up. And then just simply plus x over here. All right, so any questions about that? Let me pause there. Was that brackets and the distribution okay? All right, so now to solve for x, what we have to do is we have to gather all like terms and isolate for x, get all the x terms together and get x by itself on one side. So 39 minus 3 is 36, minus 4 is 32, minus 2 is 30. So I'm going to go 28 equals 30 is all of these numbers combined. And then with the x's, I've got, well, let's just do this first. Minus x and plus x, that's gone, right? They cancel each other out. So I have a minus 2x here. Okay. So how do we get x by itself this way now? Well, I'm going to get this is the x. It's only in one term now. That's great. I'm going to get everything else away from this x. So I'm going to subtract 30 from both sides. That's the first thing I'm going to do. I have negative 2 over here. These are gone. Equals negative 2x. Don't forget about this negative sign. Now, final step to solve for x. I divide both sides by negative 2. And I get x equals, that cancels out to a 1. X equals 1. All right, so it looks like x equals 1 right here. This is going to be 1. And if you go back and check, so the number of kids with a dog and a cat and a bird equals 1. There's only one kid that has all three. And we can certainly go back and check to make sure that this lines up with the entire situation, okay? So 13 have a dog. Well, let's just see. If this is 1 now, a dog is, 28 kids. So 3 and 4 is 1. 7, that's 8. 13, so we'd have to have 5 out here, I guess, which we're not given any indication about what this region is, but you could fill these numbers in and hopefully it'll add up to all the 28 kids. Okay? All right, so actually B does ask us about these numbers. How many children have only one pet? Okay, so I filled in the rest of these numbers because I had to make sure that each set here, so this set as a whole, for B, that's a bird, has to equal 13. So I did, this is going to get real messy here now. So I did 3 plus 1 is 4 plus 2 is 6 plus 7 must be 13. So that's how I put that in there. And for the final one, for the cat, there's 13 that has a cat, so 4 and 1 is 5 and 2 is 7 plus 6 had to be the number here to get 13. And when you add all these up together, 5 plus 3 is 8, 9, 13, 15, 22, 28. That is what our final answer is, so it all checks out. So only a dog is 5 here for B, only a bird is 7, and only a cat is 6. All right, any questions? All right, so here's the key ideas. They're in your textbook. You can look those over, highlighted by this new principle of inclusion and exclusion formula. It's a little scary, but if you take it one little piece at a time, it's going to be no problem. Okay, so look over that. And here's your assignment if you're in my class here today.